Alright, so I'm going to draw a root at the origin and one at something just a little bit bigger than 5 and something just a little smaller than minus 5. And I know that it starts out below and it goes above and below and above, and there's a good guess as to what this thing looks like. Just a guess, right? That's all we can do in pre-calculus is make that kind of a guess. In calculus, however, we're going to refine that guess a lot. So now we're ready to do that refining with the first derivative. So notice, first derivative, if I take x to the 2/3 minus 1 and set it equal to 0, I'm going to get two solutions again, aren't I? I'm going to get both 1 and minus 1. So once again, I'm going to use the test point method. Maybe I ought to try to factor this one, huh? You want to see how it would work when you factor with radicals and stuff in there like that? It's not that hard to do. The numerator is the difference of squares. The denominator, of course, is just x to the 2/3. Well, what do I square to get x to the 2/3?
1/3.
X to the 1/3. And what do I square to get 1?
1.
Very good. So y prime is x to the 1/3 minus 1 times x to the 1/3 plus 1 all over x to the 2/3. And now I can draw a more traditional sign chart. So I have three factors here: x to the 1/3 minus 1, x to the 1/3 plus 1, and x to the 2/3. Well, these three guys are 0 at -1, 0, and +1. X to the 1/3 minus 1 is negative until I get to 1, and then it's positive. X to the 1/3 plus 1 is negative until I get to -1, and then it's positive. X to the 2/3 is positive everywhere that it's not 0 because it's squared, right? X to the 1/3 squared. So I found out that this thing starts out increasing. Well, good, that's what I drew. And then it switches to decreasing. I just found a maximum. Then it continues to decrease, which is good because that's what I drew at 0, huh? That it just continued to decrease. And then at 1, it increases again, so I found a minimum. So we found extrema. We found one at -1 and one at +1. And what is the y value when x is -1? Oh, goodness gracious. +2, very good. That's what she was trying to say. And if I plug +1 in there, I get -2. It's an odd function after all. So, -1, 2 is roughly here. That's my maximum. +1, -2 is there, and now I can refine the graph quite a bit. I'm going to draw something more like this. Right? It's not quite such a smooth descent and ascent to the maximum and away from it, or into the minimum. Well, let's do a sign chart on the second derivative. Well, I've got the factor